Hello everyone and welcome back. Today we're going to be looking into a couple of methods on how to bypass anti-debugging features. The features in question will be basic and it should be easy to follow. So let's get started. The first thing that I did is I made a couple of files. The first file in question uses the most basic check, the is debugger present, which even advanced malware uses sometimes, and it uses it in the same way or in a different way. This specific method is useful to know not only for CTFs but also for malware analysis and stuff like that. The is debugger present is a simple function which is called inside of our main function in C, and as you can see, if debugger is present, it will print out debugger is present and we're exiting. However, if debugger isn't present, that means the malware can execute and then it's going to execute its code without being worried if there's a debugger debugging it and if an analyst is looking into the malware. So in our case, this actually looks more like a CTF, and as you can see, in the case of a debugger not being present, it's going to print the flag that we're looking for. Now, of course, this task wouldn't be set up the way it is right now because you can just run the program with your PowerShell or something like that, and it's still not going to obviously find a debugger. However, in this case, we want to learn how to evade is debugger present. So another program that we have prepared is the program that just sleeps for some time, and we don't want to just wait for this time to pass because it's too long. It's actually, I think, 20 minutes. I wrote this wrong, just ignore it, it doesn't really matter. And we just want to make sure that we can bypass the time.sleep. This right here in question gives us the flag after all the waiting. By the way, you might have already noticed there is solutions right here in the comments, but make sure you don't look at them because we're going to go through that step by step, and then you're going to be able to memorize everything better. So anyways, and that leads us to the last script, which just checks for internet connection. In our case, it's a little bit inverted. As you can see, if there is internet connection, it will print network connection detected and we're going to exit. In the case of malware, it's probably going to be opposite. It's going to detect if there's an internet connection to do a specific task like spread malware or something like that. But this is going to be pretty much enough just to show you how to bypass this. So after all, if you did watch my binary patching video, you will know that you can actually bypass if statements easily. However, we're going to be doing this specific task without modifying the binary. So that's going to be interesting to look at. So let's get started. So the first program in question uses is debugger present, and we're going to be looking at that right now. Let's load up our X64, and once we do, let's just pop it in. Okay, so let's run the program just to see what's going to happen. And as you can see, if we run the program right away, I'm going to have to press run a couple of times, and then it's going to say that debugger is present and that it's exiting. However, if we rerun this and take a look at our strings that we can look into by just scrolling right here, or you can just find them on a better way. So the way we're going to do this is we're just going to click right click, search for all modules, and then we're going to press string references, and then right away you're going to see your string, or you can search for it right here, but I don't have to search for it because I already see it. So we're going to double click on that, and you're going to see basically the code that we looked at, but this time in assembly, a little bit different. And one of the things you can notice is I've already put a breakpoint right here, which means it's going to stop the program before it executes all the way until the end once it hits this spot. And then also I've put a breakpoint at the end of the program so that we can see the message, because it quits right after it shows the message. So what we're going to do is we're going to run the program and we're going to wait until it hits our breakpoint. And as you can see right here, it has hit the breakpoint. Now there's a couple of things that you can notice is there has been modifications and everything, and usually there is a modification to RAX or zero flag or stuff like that when the comparisons are being done for this kind of simple task. Now I'm going to show you what actually happens, because right now it is testing the differences, but right here it is actually determining where it's going to go. So I'm going to put a breakpoint here as well, and if I press run, it is going to go here, and you're going to be able to notice that zero flag is set to 0, and you're going to be able to notice that if I put test EAX, it's going to point out the things that it's working with, and right here it looks like the only thing that this JE is looking at is the zero flag. Well, in this case specifically, the only thing that we care about that it's looking at. So zero flag right here is set to 0, and if we run it again, you will see that debugger is present. However, if we restart the program and we go back to the place that we were before, right here, you're going to notice that if I change the zero flag by just double clicking it and then press continue, it will say no debugger found. So simple as that. It looks like the is debugger present has set up a few things. First of all, it often modifies RAX and sets it to 1, but also it set the zero flag to 0. So when I just changed the zero flag, it was enough for it to actually not detect the debugger and run the part of the code that we want. The second challenge is waitforme.exe, which is the program that is going to wait, and it's going to execute partly and then it's going to wait for like 20 minutes or something, and we don't want to wait for that. So if I run it a couple of times and I can't run it anymore, and as you can see, it's saying that it's sleeping for 20 seconds. But we don't want to wait for 20 seconds or 20 minutes or whatever. So what we want to do right now, right here, is before we return so that we can see the print statement, which is right here, we're going to put a breakpoint on our return. ECX right here notifies us that 4BO, when you actually convert 4BO, it's actually 1200. I'm going to restart the program just in case, and we're going to go back to our point where we're waiting. Ignore the print, it actually defines it right now. So we're going to go ahead and press assemble, and instead of 4BO, change this 1200 to 0x1, which is going to be 1, and then that's going to be 1 second. So if we press run, it should work and it should print out the message after 1 second of waiting. So that worked. Awesome. Okay, so moving on to the last task. This task actually just checks if we have network connection, and if we do, it exits, which is the opposite of what malware might do. But anyway, we actually want to get our flag. Flag in question is actually this one, and we could do that by turning off the internet, but I'm going to show you how to do that with a debugger. So let's take a look at how to modify the program for us to move the way we want to, and to make sure that it returns the message that we want to. So for this, it's actually going to be very similar to our binary patching video. What we're going to do is we're going to search for all modules and then string references, and right here we're going to find our ping, and this is the command that we want to execute. But anyway, what we care about right now is this part right here. So we have our JNE right here. Basically, you can imagine this is an if statement, and if a certain case is met, it goes right here. If a certain case isn't met, it goes right to this line right here, which you can see right here says no network connection. This is what we're aiming for. But once we run this right now, it's actually going to say network connection detected. So if I run this, I forgot to put the breakpoint at the ending. So we're going to go ahead and do that by running preferences and the exit breakpoint. And I'm going to save that right now, and now it should be working. And next, and there we go, network connection detected. So let's retry this. And right now we're going to modify the way we would binary patch most of the tasks that we did before in our binary patching video. So you're going to get to your point, which is right here, and that is our JNE, and it's doing the comparison. And if we invert the JNE right here, it should actually work. Now we could do that, or we could just invert the 0 flag. As you can see right here, RAX is 0 already. Let's try to invert the 0 flag, see what happens. And as you can see, with inverting the 0 flag, we got our flag. So it was basically the same as if we would change this JNE to JE, but we didn't even have to patch it. But you can patch it, of course. You can just change this to whatever you want and just write this down, and there you go. So now it should print out this statement every time. Oh yeah, I forgot to say, if you're going to binary patch it, you do have to save the program, which I forgot to do. And that's 3 of our programs, and I hope that was pretty simple for you. So that's it for today. Thank you so much for watching, and if you have any questions, leave them down below, and have a nice day.